Today our goal is to apply differentiation to rates of change. And there are two types of rates of change that we need to be aware of. Average rate of change and instantaneous rate of change. Notice the difference in when we are doing these. Average rate of change over a period of time, and then see we have an interval from point A to point B in time, versus instantaneous rate of change is at one point in time, and it's not an interval, it's one specific point in time. Average rate of change is change in y over change in x, change in something with respect to something else changing, or f of b minus f of a over b minus a. It's a rate of change that's an average, like slope, or if we think of it graphically, specifically the slope of the secant line. Instantaneous rate of change at the other part of that is still a rate of change, but now this is specifically at one point in time. So how do we describe the slope at one point in time? The derivative, dy dx, or f prime of a, if that one point in time is a. Graphically, we're thinking of this as the slope of the tangent line. Now, sometimes we need to estimate instantaneous rate of change because we need to know instantaneous rate of change but aren't given enough information. So when that happens, we want to remember that we can use average rate of change to estimate instantaneous rate of change. So keep that in mind for the times where we don't have enough information. Let's look at number one. Use the function f of x equals negative x cubed plus 3 over 5x squared minus 4x to answer the following questions. What is the average rate of change from x equals 2 to x equals 2.1 of the function f? What is the average rate of change? Now, they didn't actually have to say the average rate of change. If they just said, what is the rate of change over this interval, we will understand that that's an average rate of change because it's over a given interval. That's a big deal there. So an average rate of change or a rate of change over an interval, we think of slope, change in y over change in x, or the y value evaluated at one endpoint minus the y value evaluated at the other over the x values subtracted, the difference in the x values. If we plug those in, we get negative 16.749. Remember, when we round, we always go at least 3 decimal places. We can always go more. Next, what is the instantaneous rate of change at x equals 2? Again, they don't have to say instantaneous rate of change. If they just say the rate of change at x equals 2, notice that's one point in time. This one right here, this is interval. When you have an interval, you think average. When you have 1 point, you think instant. Instantaneous, at one instance. So what is the instantaneous rate of change? Is telling me find the derivative. So first I'm going to find f prime of x, that is negative 3x squared minus 6/5 x to the negative third minus 4. And I'm going to, of course, rewrite that because the negative exponents just are not friendly, user-friendly. So that'll be negative 3x squared minus 6 over 5x cubed minus 4, but we specifically want it at time x equals 2, or at that point. So f prime of 2, then we plug it in, negative 3 times 2 squared minus 6 over 5 times 2 cubed minus 4, and can evaluate that as negative 16.15 exactly. So again, notice the difference between giving an interval, you find an average, giving 1 point in time, and you're finding at an instant is always derivative. And I pulled this from an AP exam. Using the graph at the right, experiment population of bacteria, find the average rate of change. Average rate of change, what do you want to do? Change in y over change in x, the slope formula from P to Q. Well, if I'm looking for the change in y over the change in x, those are what I need to find. Here are the y's, 340 minus 150 over, and here are the x's, 45 minus 23. Leave it like this or simplify it a little bit, 190 over 22, or simplify it a lot so that it makes sense to you. It's about 8.636. What did I measure on top? The y. What was the y units? Number of bacteria. So bacteria. What did I measure on the bottom? The x. The x is measured in number of days, so bacteria per day. Keep in mind, if you just give an answer that's bald, meaning you don't show work or you don't give units, you will not get any credit. So answer with units if you can, always. Second, equation for the data can also be modeled by this. The average rate of change, again, average. So again, change in y over change in x, or looking at this interval, I want the y value at 3 minus the y value at 1 over 3 minus 1. Well, find those y values. Y of 3 is 3 cubed minus 3, or 24. Y of 1 is 1 cubed minus 1, or 0. Plugging those in, 24 minus 0 over 3 minus 1. Leave it like that if you wish, or simplify it into 12 and put your units, bacteria per day. You need your units to get that answer correct. Finally, use the same equation as in part B to find the instantaneous rate at 3 days. That's the derivative, so that's y prime at 3. But first we need to find y prime. 3x squared minus 1 is the derivative. Plug in the 3. 3 times 3 squared minus 1, and that makes 26 bacteria per day. If you do not have units, it is not a correct answer. Let's do one more. Maybe you give this a shot yourself and come back. Welcome back. From an AP exam, estimate the derivative. Well, I don't have a function, so I can't take the derivative, but I know derivative means rate of change or slope. How do I estimate a slope? I do change in y over change in x. Well, which points do I use? If it's the year 1870, perhaps we pick a point before and a point after. Any 2 points you pick really around 1870 are going to be fine as long as they're pretty close. So the function values are these on the bottom. So I'm going to do 50.2 minus 31.4 over 1880 minus 1860. Leave it like that if you wish, or simplify it so that you can see if your answer looks logical. 0.94, what are our units? The function values were the top. So the top is millions of people. The bottom is the years, so millions of people per year. You are going to have to know how to interpret the meaning of your answer. You will have to know how to do that. So let's think this through. First of all, we're finding the rate of change at one point. So let's start with that point in time and say at this point in time in 1870, not during 1870, not over the years spanning around 1870, but in that year, at that point in time, one point. What are we measuring? A population. The amount of people. So I'm going to describe what is it I'm measuring. The population, what's happening to it? It's getting bigger. So the population is growing. It's growing or it's changing, but growing's a little bit more specific because that's true. It's growing at the rate. What did we find? A rate of change. So it's growing at the rate of, I'm going to say about because we did estimate, so it's growing at about 0.94, and then our units, millions of people each year or per year.